This is an introduction into kinematics, and so kinematics is just the study of motion. And without the care of the cause of the motion. So it's just actually studying the movement. Okay, so it's the study of how objects move. Okay, so whenever you're driving in a car, the speedometer is the thing that actually tells you the speed of the car. So that this quantity is actually instantaneous. And what that means is it's just telling you the exact speed that the car is moving at that exact time. Okay, so if you slow down, it's going to respond to that and tell you the different value of your speed. Okay, generally in kinematics, we're actually looking at average speed. So to find the average speed of a trip, you would need to look at your odometer. And so your odometer is kind of like your trip button. It's usually up by where your speedometer is. There's like a little button that you can hit and it keeps track of how far your trip has been. That's your odometer. So using the total distance traveled and the total time of your trip, you can then find the average speed. So speed tells how fast an object is moving, but not in which direction. So speed, distance, and time are all called scalar quantities. And so basically a scalar is going to have magnitude but no direction. So we might say we're traveling at 100 kilometers per hour for 4 hours. We can say that we've traveled 400 kilometers. So these values have a magnitude, which is basically a value or a number that's associated, but no direction. Okay, so I'm not telling you how far from my starting point or which direction from the starting point I went when traveling. Okay, but generally physicists are actually concerned with direction. Okay, and so these quantities have magnitude and direction, and they are known as vectors. Okay, so they're going to have both a number with a unit associated with it, plus a direction. So it is written in this order, and it will be what I expect from you guys. So you'll have the magnitude or the number basically, the units, don't ever forget units, and then we put brackets around the direction. Okay, so this is how I will expect to see your answers written out. So when writing the variables associated with a vector, that variable has a vector arrow. And sometimes it is referred to as a hat. And so what it's referring to is this little arrow on top of like the V that is just letting us know that this is a vector. So it's expected to have a quantity and a magnitude and a direction. Okay, and so you can see they've kind of written out. So we have 4.2, which is our magnitude, meters per second, which is our units, and then E, our direction, which is east. Okay, so vectors are going places, so they have direction, so they need to wear a hat. It's kind of an easy way to remember that you need to put arrows over those quantities or over those variables. So there's many different types of vectors, and so we're going to kind of just go through the different things that we're going to be looking at in this section. Okay, so position, it's denoted with a D arrow. Okay, so it is the location of an object relative to a reference point. Okay, so this reference point is the important part of that definition. Okay, and we'll go through examples whenever we get further in. Okay, displacement, this is going to be change in position. Okay, so the change in position. And using our examples here, we'll kind of go through each of them. Okay, so for example, let's say we have this starting point. We'll just make it a flag. Okay, so this is going to be our reference point. Okay, and say there is a person standing here. Okay, and then this will be west, this will be east. Okay, and this person is 5 meters away. So if I wanted to state the position of the person in reference to the reference point, he would be standing 5 meters east of the reference point. Okay, compared to displacement, if we have the same person, so we have our arrow, the person starts 5 meters away from the reference point, and say that person then walks to the east and ends up 7 meters from the reference point. Okay, our displacement is our change in position, so it's going to be this quantity. So we would take 7 minus 5, and our change in position, or our displacement, is 2 meters east, because that's the direction that he walked. Okay, so this street scene helps to illustrate the difference between distance and position. See the reference point to be, or set the reference point to be the cinema. So I'm going to go ahead and kind of mark the cinema as our reference point. So I'm going to make it green, just so I can remember that is our reference point. Okay. So if we exit the cinema after watching a movie, what's our position? Remember, the position is relative to the reference point, so to the cinema. So if we come out of the cinema, the distance from the cinema would be 0 meters. So our position is going to be 0 meters. And what's the total distance that we've traveled? 0. Okay, because we haven't walked anywhere yet. All right, you walk to the post office. What is your new position? Okay, so remember the position is relative to the reference point. So if we walk this way, we would have, our new position is 23.4 meters east. Okay, our distance, which remember distance is just a scalar, so we don't need direction. The total distance that we've walked so far is 23.4 meters. You walk back to the cinema. What is your new position? Okay, so if we walk back to the cinema, in reference to the cinema, our position is at the cinema. Okay, so our position is going to be 0 meters again. Okay, but the total that we've walked is actually 23.4 plus the 23.4 it took us to walk back. So our total distance traveled is going to be 46.8 meters. You walk to the bakery. What's your new position? Okay, so we're going to walk all the way over to the bakery. Okay, so in order to find our new position, we're going to add the 23.4 plus the 37.7. So our new position is going to be 61.1 meters east. Okay, and our total distance traveled, we're going to add on to the 46.8 that we had before, plus the 61.1 that we just walked. So our total distance is going to come out to 107.9 meters. Okay, so remember, position is relative to that reference point. Okay, so comparatively, moving on, this street scene helps to illustrate the difference between distance, position, and displacement. Okay, so set the reference point to be the post office. So I'm going to box off our reference point. Okay, you exit the cinema after watching a movie. Okay, so we are starting basically right here. What's your position? So this position, it's going to be different than the last practice problems because our reference point has moved now to the post office. So we are actually, our position is 23.4 meters to the west. And the total distance we've traveled is 0 meters because we haven't walked anywhere yet. Okay, you walk to the post office. What's your new position? Okay, so if the post office is our reference point, that means that our new position is 0 meters from the post office. Okay, what is our displacement? So our starting point was here. Okay, this was our starting point. So displacement is going to be what is our change in position from that starting point. All right, so we are from the starting point because now we're standing at the post office. We are 23.4 meters east of where we started. Okay, the total distance that we've traveled is just the 23.4 meters it took us to walk to the post office. Okay, you walk back to the cinema. What's your new position? Okay, so if we're at the cinema, we are 23.4 meters from our reference point, which is the post office. So our position is 23.4 meters west of our reference point, the post office. Our total displacement from the starting point, which was at the cinema, we are at a displacement or change of position of 0 meters. Okay, when it's 0, we don't have to put a direction. And then the total distance traveled would be the 23.4 meters to the post office and then the 23.4 meters back to the cinema. So that's going to be a total of 46.8 meters. Okay, you then walk to the bakery. What is your new position? Okay, so for position, the bakery to the post office is 37.7 meters to the east. Okay, our change in position or our displacement. So from the cinema where we started to the bakery, we would do 23.4 plus 37.7, and we would get 61.1 meters to the east. Okay, and then the total distance that we've traveled, we had already traveled 46.8 plus an additional 23.4 plus 37.7. We have a total distance traveled of 107.9 meters. Okay, and then we walk back to the cinema. Okay, so when we walk back to the cinema, our position from the post office is going to be 23.4 meters west. Our displacement, because we're back to where we started, is going to be 0 meters. Okay, and then our total distance, we have to add back another 37.7 plus 23.4 to our last total, which was 107.9, to get a total of 169 meters. Okay, so remember, displacement is the change in position. Okay, so when the starting location and the ending location are the exact same, the displacement is going to be 0. Okay, this means if you were to run an entire lap around an oval track back to the point where you started, your total displacement would be 0.